You're welcome to another video of the course IPv6. In this section, I'm going to discuss IPv6 link local address, which plays a critical role in IPv6 network, and it has applications like neighbor discovery and automatic address configuration, and it is essential for proper functioning of IPv6. IPv6 link local address is always present on an IPv6 interface, even if other address types are already assigned to the interface, like global unicast address or a unique local address. This is IPv6 link local address format. As you know, it begins always with FE80/10, but a subset of this prefix, that means FE80/64, is usually used for link local address. That means the other 54 bits are always configured as 0. And the second part of link local address is interface identifier, which is the other 64 bits, and it is usually generated from MAC address of the interface using EUI64 mechanism, which we will discuss in a few minutes, or it is generated randomly, which is the default behavior of some operating systems like Windows. As I have mentioned, there are two methods to generate interface identifier of link local address. The first mechanism is to generate from MAC address, and this is called EUI64 mechanism to generate interface identifier from the MAC address. To give you an example, this is the MAC address, and this is the mechanism to generate 64-bit interface identifier from the MAC address. We insert FFFE exactly in the middle of the MAC address. That means we make the MAC address in two parts, the first part and then FFFE, and then the second part of the MAC address. And the other changes, we change the 7th bit of the MAC address. If it is 0 to 1, which shows it is a locally administered address, and that means here, after inserting FFFE in the middle of the MAC address, we change 00 to 02, which is the result of changing the 7th bit from 0 to 1. To demonstrate a real example from link local address and how interface identifier is generated from MAC address, I've created two routers and connected them through two interfaces, ETH00 and ETH01. And now I will connect to one of these two routers, for example, IOU1. And in IOU1, the only configuration that I will do is interface ETH00 and no shutdown and IPv6 enable. If we check the MAC address of the interface with command show interface ETH00, you see here the MAC address of the interface AABBCC and up to 100, and then we will also check the IPv6 address of the interface. However, we have not configured any IPv6 address. And with command show IPv6 interface brief, we see that the link local address is automatically generated, and the first part of the link local address is a fixed prefix FE80/64, and the second part is generated using EUI64. How can I make sure that it is generated using EUI64? This is because I can see FFFE in the middle of the automatically generated link local address. And if you check again, RRBBCC, and here is R8, because the 7th bit of the MAC address is changed to show it is locally administered, and then BB and CC, and then FFFE, and then the second part of MAC address. So this is a link local address which is automatically generated from the MAC address using EUI64 mechanism. Now if I check the link local IPv6 address of my Windows with ipconfig command. This is the link local address of my system, and if you check, you see no FFFE in the middle of link local address. That means it is generated randomly, which is the default behavior of Windows operating system. However, we can change the default behavior to generate interface identifier using MAC address, but because of privacy and security, by default Windows generate interface identifier randomly. And if you check also the default gateway, you see the default gateway is FE80::1, which shows two important points. First, the link local address of the gateway used as default gateway. However, the gateway, the router, has other address types, but always the link local address is used for internal and inside link communication. And because of that, always when we create a static route, we use the link local address as the next hop, or all dynamic routing protocol use link local address as the next hop in routing table. And the second important point here is that the link local address of the router is not generated automatically using EUI64 or randomly, but it is manually configured. And it is a best practice to configure link local address of the routers always manually, which makes the troubleshooting easier and easier to understand what's happening in the network. You see also %2 at the end of link local address or default gateway, which is the interface number of my Windows, which we don't discuss about it at the moment, but probably in the next lessons. As I have mentioned, it is a best practice to configure link local addresses on the routers manually. However, it's not a best practice for clients. In the clients, usually link local addresses are generated automatically, but for the routers, it can be a good practice to configure link local addresses manually. To show you and demonstrate how we configure manually the link local addresses on the routers, I've created two routers connecting through two interfaces, ETH00 and ETH01. You know, link local address is locally significant and locally inside the link unique. That means two different links or two different interfaces have always link local addresses in the same subnet. That means here is FE80/64, and exactly the same subnet will configure in the second link. Always link local addresses are in the subnet FE80, and it must be just locally unique inside the link. That means the IP address of router 1 and router 2 in the same link are not allowed to conflict, but in two different interfaces in the same router or in two different routers, probably exactly identical IPv6 link local address will be used, and it is completely normal. And because of that, it's a good practice to configure all interfaces of a router with the same link local address, which simplify to identify the routers easier and also make it easier to configure, for example, a static routing or make troubleshooting. So I will choose FE81 for the link local IP address of ETH00 and also ETH01, and FE802 for link local address of the second router in both links. Here means both links have the same link local address, but in the same link, two different routers have different link local addresses. And because of that, we can easily identify routers when we troubleshoot the network and see the routing table. And to demonstrate that, for example, we go to the router 1 and we configure interface ETH00 IPv6 address FE801 link local. This is the syntax to configure the link local address of interfaces in Cisco iOS routers, and we configure exactly the same for other interface. Make sure the interface 00 is also enabled. And for router 2, interface ETH00, no shutdown, IPv6 address FE802 link local. And exactly for the other interface, FE802 link local. As you see, all interfaces of the same routers have exactly the same link local address. And it can be a good practice, especially when we configure routing in the network. But now the question is, when we ping from router 1 to router 2, how router 1 can understand which interface will be used as outgoing interface. This is a problem of link local addresses because all interfaces have link local address in the same subnet. And because of that, always when we want to communicate with a link local address, we have to specify the outgoing interface manually. It doesn't matter when we ping a link local address or when we want to use a link local address as a next hop address in the static route. When we configure a static route and we want to use a link local address as a next hop, we have to also configure outgoing interface alongside link local address. And without outgoing interface, communication with the link local address does not mean. And because of that, you see in Windows, whenever there is a link local address, there is an interface identifier alongside link local address. You see here also for the link local address of the interface, it says it belongs to the second interface. And that means here, when I want to ping FE802 from router 1, you will be asked to specify the output interface. And I can say the output interface is, for example, ETH00, and the ping is successful, or I can specify the output interface at ETH01. And in both interfaces, we have FE802 configured in the second router, and because of that, the configuration is successful. As I have said, it applies also when we configure a static route. For example, we will discuss about a static route in the following lessons, but at the moment, just to show you the importance of configuring outgoing interface beside link local address. When we configure an static route, for example, a default route, we have to specify the outgoing interface, for example, 00, and then the next hop, FE802. And it is wrong when we configure the link local address as the next hop without outgoing interface. Interface has to be specified for a link local next hop. And as a final point, it is important again to emphasize that link local address plays a critical role in IPv6, and without link local address, we cannot expect a proper functioning of IPv6 because many applications like neighbor discovery, automatic address assignment, ARP or duplicate address detection, and many other basic and fundamental mechanisms in IPv6 are dependent on link local address.